A great starting point is downloading a hypervisor. I would suggest using either of these: VirtualBox, VMware Workstation, or Microsoft Hyper-V. To make it as easy for you as possible to follow along, download and install either of these Linux distributions as your attacker machine: Kali Linux, Parrot OS Security. Once installing the machines is finished, please make a full update. Since these are Debian-based systems, open a terminal and use this command to update: sudo apt update and sudo apt dist upgrade -y. From now on, everything will be done through your attacking machine, Kali or Parrot, as this challenge is supposed to be a blind one. The objective is to find one flag, hence the name Capture the Flag. Different challenges contains a different number of these flags. This one requires us to find just one. Flags are usually a text file called flag or a string with the word flag in it. First of all, make sure you know your own IP address by opening a terminal and typing IP-add. Take note on which subnet you are residing. In my case, my IP is 192.168.148.130, which means my subnet is 192.168.148. Before we continue, let's make a directory that will contain our future findings. In Linux, it is as important as in any other operating system to keep organized. Instead of having to move a lot of files later, let's create a directory from which we will work on this challenge and save information there if needed. First, make sure you're in your home directory by typing cd:\tilde. If you haven't already, create a folder called vulnhub, and inside that, create a folder called matrix2. Finally, enter that folder. In the beginning of every CTF, I like to get to know my surroundings. My surroundings are always contained to the immediate subnet in which I reside. So let's do a simple nmap scan of our subnet to see where the machine we are going to attack is located. nmap space 192.168.148.0/24. As several results may come up, you might have to use your deductive skills to single out the machine that we are going to attack. I, in my case, know my own machine is not serving HTTP, so this must be the machine that I'm after. Since we now know the IP address of the target, let's make a more comprehensive scan on just that machine. nmap space dash capital A space dash capital T4 space dash P dash space the IP address of your target machine space dash O capital N space scan.txt. These are the ports that I find open and the services enumerated by nmap on those ports. I have port 80, which is serving HTTP. I have port 1337, which is serving HTTPS. The same goes for 12320, 12321, and 12322. So we now know there's a web page served on the first port, port 80. Let's go there by typing the IP address of our target in a web browser's URL field. This is the web page. There's nothing to click on, there's no links. So there's nothing that I personally find useful here. So let's view the page source. There is a script source link here, which points to a JavaScript file called index. How about we add that file name to the URL? Inside the contents of the JavaScript file, there's a line that tells me a few things, maybe. It hints to port 1337, which is open as we saw on the Nmap scan. It also has the text crash code, which might stand for broken code. We see the words hacked and breached system as well. I am eager to go and check out port 1337 now, since it's been hinted to us in the JavaScript, and we also know it is serving a web page. Let's head over there. When we add the port to the URL, we get a 400 error, which means bad request. If we check back on our Nmap results, we can actually see the problem. It is using SSL, thus it is an HTTPS web page. We need to specify that in our URL. When we do that, the first thing that happens is I am prompted with a warning, and if I proceed, I'm giving a login prompt. We don't have any credentials to log in yet, so this is a dead end for now. Let's go check out the other ports that were open. Once we do that, we find that 12.3.20 has another login page, while 12.3.21 is not opening. And 12.3.22 redirects us to the main web page once again. So what to do now? Well, another low-hanging fruit was right in front of us in the Nmap scan. On port 12.3.22, there was an enumeration showing us a file called robots.txt. Robots.txt is a configuration document file that is stating any disallowed files or directories on a website. This file is not supposed to be visible to anyone, only the web admin. However, in some cases, this file is not made hidden. How about we check for it? We can simply add it to the URL on port 12.3.22 and try it. Once we access the robots.txt file, it is stating that file_view.php is disallowed. Well, we know we shouldn't see that, so let's use it. Let's head over to check out the file. But when we add the file name to the URL, we can see it's just a blank page. Let's do the next smart thing and view the page source. We can see the message, error, file parameter missing. Hey, I know something you may or may not know. In the source of the page we find and the error message saying a file parameter is missing. This means that the web page is trying to request this file_view.php file, but a parameter is missing to finish that request. In most cases, this means there's a possibility for local file inclusion, since something is included from the server in front of our eyes, which is the error itself. We can try to manipulate what the server is showing us. Instead of this file, why not something more interesting, like usernames or passwords? So in short, we have found a robots.txt file stating that there's a file disallowed on the web server. This file is called file_view.php. We are not supposed to know this, but as we now do, we can now manipulate the server through us knowing that file name is a valid file on the server. We know that the system OS on the target is Linux. This in turn means the target is serving its website from a very specific folder. /var/www/html. This is also called the web root directory in Linux. We also know that if we want to find usernames and passwords in Linux, we should look in etc/password. We might have the possibility to move from one directory to another because of knowing where the file_view.php is located. Let's use a great program called curl. Curl is a great program for posting and fetching, amongst others, HTML traffic and information. Let's try exploiting a local file inclusion vulnerability and see if we can enumerate some information from the web server and maybe even beyond. Let's use this command. Curl is simply invoking the program. -X means the HTML method we are going to use. Post means we're going to post something to the site. -K means disregard any SSL insecurities. We are then specifying the target's website with the correct port 12322, and the file that we already know is sitting there on the web root, file_view.php. We are then specifying the data with the -D that we want to extract. We want to look for a file in the etc directory called passwd. In this technique, you will have to use trial and error, not knowing exactly where the etc password file is located. Or do we? How many ... slashes do we need to get to the right directory? Well, we know if we want to back up one directory in Linux, we simply do ... or cd space ... Actually, we know the web root directory is /user/home/var/www/html. So let's just step it back gradually. When we have added some ... slashes a couple of times, we get the results we are after. Here's what we get. We can now see a list of users, and I'm noting the username N30. Since we know this is a matrix box, let's just call it Neo. Let's save that for later. I will just open a text editor and keep it in front of me for future use. Maybe we can find some more info through web server local file inclusion. We also do know that the service is running Nginx. Nginx is an HTTP web server that with a little searching online has a directory called Sites Available, which contains the web server's present web pages. In there might be some more info for us. Let's look for a file in that directory called default, since this file holds the default configurations for the site. We already know where the etc directory is. Now here's some interesting files configured. How about this .htpasswd? Let's go looking for that with curl. Sweet! some new credentials. Well, at least parts of it. We found a username, Trinity, which we will put in our document. We also found a hashed password. For this, I could use a program like John the Ripper to brute force the hash, using a word list. John the Ripper takes all the words in a word list, hashes them, and compares the hashes to the given hash that we found. If it finds a match, of course, it has also found the password in plain text. What we need to do first is make a file with the username and the hash. I made a file called hash, then used vim to open the file and paste the username :hash inside. Now when that's done, we can use John the Ripper to try and hack the hash. John space hash space dash dash word list =/ user / share / word lists rocku.txt. Yes, it gave us a password to go with the username Trinity, admin. Let us take note of these credentials and use them to try to log in on port 1337, which had the login prompt pop up. We are now allowed to log in and are shown a web page with a bit of different text than the public one. One thing I notice once again is the name Neo. When exploring the page source of the web page, it shows us a line that says hidden.jpg. That surely fuels our curiosity, so let's have a look. This is what it shows us. We see a picture with nothing more than a quote from Morpheus, but why use the word hidden in a file name? It seems the picture is not really worth hiding, or maybe the picture itself is hiding something. There is a way to disguise files as something that they are not. One way is to hide data inside a picture. To do this, somebody could use a program like steghide. This is a tool both to hide files in other files or extract hidden files from other files. Let's download the picture to our Matrix2 directory and try extracting hidden data with steghide. Since steghide is not included in all penetration testing distros any longer, you might have to download it. First, type which space steghide to see if it's already installed. If not, Google steghide download and find the GitHub page for steghide. Press the green code button and then copy the URL to the clipboard. Then use this command to download and install it. Once installed, we should be ready. With this command, I am telling steghide to extract from a specified file what it finds, and print it into a file called Neo. I am naming the file Neo, since I know Neo is the user we still haven't found a password for. When steghide is done, I have a new file in the folder called neo.txt. Let's look at it. Cat space neo.txt. Lo and behold. So now we have some new credentials. Let's take note of these as well and try to log into port 12320, the only other port which we haven't been able to log into yet. Hey, it worked! We are inside the system. We can't really do much in here at all. The shell is not letting us see any files or poke around in the directories. Since we are already in the system though, I think we can exploit it to give us a better shell to work with. One of my favorite shells is the MetaPredator shell. It allows us to do a great deal of things and is easy to work with. The easiest way to exploit this system now is to run some sort of exploit directly on the machine that we are logged into already. Let's use the mother of all frameworks to make an exploit for us. Metasploit. Metasploit is a framework containing thousands of modules for exploitation, scanning and enumeration, firewall evading, and much more. To start this framework, simply type msf console. This will engage the Metasploit framework console. When all is loaded, it will look something like this. How to know where to go from here? Well, we are logged into a shell on the web, which means we will have to use some kind of delivery system for our exploit that will work on a web page. If I search for web, I will soon find an exploit that is called web_delivery. I can see that it is an exploit in the form of a script, which I then could run right on the web shell. To use it, I will just enter use and the number of the exploit. Now our prompt has changed, and we are now using this exploit. We can now also see that the payload this exploit will build for us is a MetaPredator shell, my favorite, built with Python. To get this exploit built and working for us, we first must see if there are any parameters we need to give to the module before we run it. Let's view the options by typing options. Here we can see which options are available to us, and most importantly, which are required to be set. We can see that the server host is not set, and the local host is not set either. These parameters are supposed to be pointed to our machine, to both serve the session and maintain it. So let's set these parameters by doing this.
Through the fields of our paths, feelings part our ways, keeping us close but estranged now. Dreams holding us closer, meadows of our youth. 107 days, but recalling it backwards.
View your options again by typing options to see if they now look correctly set.
We can see so clear.
Then type exploits.
See so clear.
We can now conclude a few things. The exploit is now running, and it has created a reverse TCP handler on our IP address on port 4444. This means that it's listening on that port for TCP connections. It has also started one job as a server on port 8080, which is also on our IP address. To make the target initiate a connection to our MetaPredator shell, we simply have to copy the Python code that Metasploit has built for us and run it on the target. So let's do that. Let's copy the command created and paste it on the target machine. After pressing enter, nothing noticeable has happened. But let's look back at our terminal, which has Metasploit running. We can see that the payload has been delivered to the target, and that MetaPredator session 1 has been established between the two machines. Let's enter the session by typing sessions space 1. We now find ourselves in Neo's home directory. Let's start a bash shell here by typing shell. And let's check who we are by typing ID. We are user Neo in the group Neo. If we ls, we find a handful of files. The one that stands out to me is the .bash_history file. In this file, commands that have been used in the past on this shell is stored. So why not look at that? cat space .bash_history. Well, somebody has changed ownership for just about everything, including root, to the user Morpheus. And most importantly, Morpheus has then started a shell as this user to cat the flag. Let's also do that by copying the shell command from the history and executing it in our MetaPredator session. Would you look at that? We are still Neo, but we have an EUID that is root. EUID is the effective user ID, and it's the ID that the current process is executing as. So anything we do now is processed as root. So we can now look in the root folder. Well done! I truly hope you enjoyed this walkthrough and learned a few things along the way. Remember that nobody will ever be a fully trained penetration tester, and that it is up to you to seek knowledge and practice your skills at the best of your ability. And always, make sure that you are using these techniques only on systems and networks you have permission to do so on. See you in the next challenge.